Morning, everyone.
Morning.
Attendance and then we'll get started. What is today? Friday. Aaron, Don, Brady,
Kenzie was here a little bit ago, and then she disconnected. I think she might have some connection issues going on. Oh, there she-
All right. Ready to do some HMI stuff?
Sure.
You excited about that, Brady?
I mean, sounds like I'm a little more excited than anyone else.
Yeah,
Okay.
it sounds exciting.
Oh, there we go.
All right. First thing we need to do is ran into problems last time because we didn't have any inputs to tie into our program. So I'm going to need help with this. If somebody can get all the inputs and outputs pulled up.
I'm working on it.
What we got to do is all the inputs that we're using for our program, we need to parallel a B3 around them so we can pull that bit up in our HMI software. Okay. We've got this B37 around our temp control run bit. Let's rename that. And so selector left, that's our enable, like process enable. Hello?
Yes.
Yeah.
You guys got to help me out because I've been working with everybody in all their groups and I have all these different processes in my head. So
Sorry, go ahead.
I don't remember this process. So selector left, that's our process enable.
No, I don't believe so. Let me check. I wasn't on that. I was on that. It is? Okay.
Yeah. It is on there.
All right. So we need to add a B3 for all of these inputs. All the push buttons and selector switches and proc switches. HMI, process enable. Proc switch is our kill switch. Is that right?
Yes.
Yes.
So we need to add an HMI kill switch. So this will be HMI e-stop. Make that B39.
I missed it. Start from the beginning.
Nope,
Zach, start over, please.
ain't happening.
Dude, serious?
We're not, all we're doing right now is adding B3s to all our inputs so we can put them into our HMI program.
Oh. Are we gonna have to connect the HMI for our final?
No,
All right. Well, then I'll see you guys Monday.
see ya.
I'm just kidding.
It's awesome that you can design like essentially what is like I forget where I was even going.
Yeah. How come we haven't just muted Nathan yet?
Okay.
That was last week.
Oh, poor Nathan.
That's every week. Don't worry. That's every week.
All right, is that all we have for inputs? We're not using the yellow button or the red button?
I'll go back to the process.
Oh, I think I got it pulled up.
Yep.
Okay, and that's fine.
Is it?
The only other thing we need to do is we need to decide, are we going to display temperature in Fahrenheit? Are we going to display temperature in Celsius? If we do, we need to make sure we have an F8 value.
The process says it has to display the temperature in Celsius.
On the 3-digit display. I'm talking about displaying it on the HMI.
Ah,
So like if we look at all these values that we have, like we can use the HMI to display to the user what the fan speed is, what the temperature is in Fahrenheit. So F83 is going to be temperature in Fahrenheit.
Will we be able to do that? I remember the last time we were trying to do this, we were having some trouble exporting the PLC program to the HMI.
Yeah, I got that fixed. So
okay.
was just, I just had to change the IP address settings, and like the laptop and the HMI and the PLC all have to jive with their IP settings. So that's all good. We're communicating just fine now.
Okay.
Now we just need to make sure we have in our program what we need. So somebody write down that F83 is temperature Fahrenheit. F81 is temperature in Celsius. What else do we want to display? We can display all the pilot lights. Those are all ready to go. We don't need to do anything there. We might want to display the speed of each fan in like a percentage. You guys want to do percentage or hertz?
Hertz.
What class is this technically? 232?
32.
All right. Well, no, I was just wondering for the, like, what I'm looking at under Blackboard.
We should do temperature in Kelvin. Just
Oh,
kidding.
good
That was a joke.
All right, I'm just going to add a couple rungs here because I don't think we have any F8 values that are fan speed. So I'm going to make, let's see, compute. What did we decide? What did we just use? 7 and 8? What do we use? F8 what?
F8.3 for temperature in Fahrenheit. F8.4 for temperature in Celsius. 1.
No, F81 for Celsius.
So we're
Right.
using 1, 2, 3. So let's call F84 will be the temperature in, or no, fan speed, exhaust fan speed. That's not what I want. So how do we find the exhaust fan speed? Any guesses?
Well, don't we have it set to 65%?
Yeah, but we want it in real time what the fan speed is, just to show the user.
With the VFD?
Yeah, so anytime we change the fan speed, it'll show it on the HMI.
Does the HMI have like a compute function, or could it be connected to a compute function on the?
All it's going to do is take the tags we have in the program in the PLC, and it's going to sit there and read the PLC program, right?
All right.
PLC is going to tell you this F8.1 value is 34.9569er, and it will take that information and do whatever you want with it.
Okay.
So right now, what I'm saying is if we had the output of the exhaust fan in here,
Channel 0.
and that would be a 4 to 20 milliamp signal, right?
Yeah.
So this is the exhaust fan output. So 4 to 20 milliamp would be 6241 to 31206. So are we going to go 60 hertz, or are we going to go hertz, or are we going to go percentage? What do we decide?
Hertz.
Hertz. Okay, so how do we interpolate those numbers, 6241 to 31206? And this will be the same calculation as the temperature fan, 6241.
0 to 60.
31206. So F8.4 is going to be somewhere in here. So we want to take this value, which is local 6 output channel 0 data. So I'll just say 6 out. Whatever that happens to be at the time of the program, we want it to spit out a 0 to 60 number. So how do we do that?
With a
If 6
compute.
out happens to be 20,000, we would take that number and do what? We'd find a percentage of this range, right?
Yeah.
So we're going to take 6 out. And that's our output number, minus 6241. We're going to take that divided by the whole range. Following me? And what does this value give us when we calculate that?
They'd give us the percentage.
Yeah, that would give us the percentage of this range, right?
Yeah.
Very good. And we're going to take that percentage and apply it to this range. So this whole formula times the range of 0 to 60 is just what? 60.
Yeah.
So our expression would be local 6 whatever minus 6241
Divided by 31,206 minus 6241.
that whole thing times 60. This one we're going to call F85. And that's going to be temp fan speed. The only difference is this. I think it's going to be channel 1 data, right? But we can just use the tags. So it'd be 6 out channel 1 data. Cool?
Yep. We're doing that because we want to control the temperature cooling fan.
We're not using these rungs to control anything. We're
Well,
just
yeah,
assigning
compute the.
the Hertz value to an F8 number. Then
Yeah.
when we open up our Seymour HMI software, we can use these numbers on a display screen that shows you the exhaust fan right now is at X amount of Hertz, right?
Yeah.
Cool. All right. And then I'm going to save the XML file. I'll save that as 4.4. I'm going to go into Seymour. And I'm going to whoops. Database, tag name database, import 424. This device, overwrite existing tags, import, filter. There's all of our tags that we just imported. We should have an F8 whatever. Yeah, but the description, I wish it would bring the descriptions over too.
Now, is that because it's older software, or does it just not bring the descriptions over at all?
I don't know
ever?
if there's a way to do it or not. It just, I guess when you save it to that L5X type file, it doesn't save the
The descriptions.
descriptions.
Okay.
I think if you had your own tag names, like if we went through each of our tags that we were going to use and made our own tags, it'd be easier that way to figure out what we were using. But that's just not how I personally write the software or write the logic. So, but it's okay. We've got a list in front. Somebody's got a list in front of them, right? Of what we just talked about.
Sure.
Good.
Mhm.
Okay, I'm gonna start over with this screen. So here's all of our screens. I'm just gonna delete this one for now. I'm making screen 1.
You got a stop button.
We do. Screen 1, we're gonna have, what are our inputs? We've got e-stop, the 3 B3s that we put in there. We've got e-stop, we've got
Control on.
control on, and temperature control start,
Mhm.
right?
Right.
Okay, so let's edit this one. Name, e-stop. I don't care about all this stuff. Tag, we're gonna make that B. Is it B? What is the e-stop? B3 what?
9.
9. Thank you, somebody. Brayton. B3 9. So we can have the object type be toggle. That's a normally open push button, right? And in our logic, all we need to do is momentarily energize it, right?
Right.
So
Yeah,
we're going
right.
to change it to momentary on, which will make the bit untrue, and yeah, so on and so forth. B39, text size. So we'll make it, we want it to be dark red. We want to say e-stop. Bigger. Whoa. And when it's energized, just when I depress that button, we'll make it say stop, and we'll have it like a bright red. then if you want to simulate it over here, so right now it would be in the off or de-energized state. And then when the HMI is loaded, I press that on the HMI and it will momentarily turn to that. And then I let go and it'll turn to that. But it should stop the software.
Wow,
That's
What?
cool.
that's cool.
Isn't it though? Well, hopefully we're doing it right. That's the only thing. We could put different types of buttons in here. Maybe we will. But all I did just there, so this stuff is really easy to manipulate. But all I did was Control C and Control V, just copy and paste. And then now I can just change this one to, this will be our control on. What was our B3 whatever? Process enable is B3.8. We want that to be like a green, right? And then when you depress it, it'll be something like that. Process enable, and make the text size. So we'll say enable. Okay, so that's what will happen when we do that. That's going to be a momentary on. And then temp control start will be the next one. Was B39 the right one? What did we say it was?
I don't remember.
3.9 was the stop. B3.8 was the process enable.
Thank you. Okay, and then this one will be temp control. What do you want to do with this one? Make it like
Pink.
Yellow.
Pink.
let's make it yellow.
That's puke green, sir.
Let's make it puke green and like doesn't look that great.
I figure we should probably make it the same color as the e-stop. And then that way, if somebody needs the e-stop, they don't know which one to hit.
That's a good point, John.
Good idea. Good
So,
idea.
yeah.
Yeah.
Throw them off on the panic crush.
Right.
Just saying, I thought we were here to destroy things. Maybe I misread that.
So we're kicking John out today, or
Wait, speaking of destroying things, did you ever change that fuse out? Or was it?
no, it's still. I do have some more fuses, but that's a great question.
I think he's got a bolt in there
Oh, that's
instead.
cool. Look at these things. Look at this, huh? Look at these little shaded doodads.
A red start
Oh
button.
my
That's
gosh,
deadly.
okay, those are cool.
Bill effects. This is cool. Let's do something fancy.
So I know you said it wasn't required for the final, but can we do that on the
Yeah,
final?
if you have extra time, heck yeah. So,
I will not have extra time.
You're already planning out that you don't have extra time.
so simulate it. Yeah, I don't know what this is. I'm getting out of here. All right, right now our background is just a gray screen, but we can do some fancy stuff there. So this is just going to be screen number one. It's going to be the control screen, and eventually we'll have other screens that will display other things that we want them to do. But right now, this is a good place to start. So background, we're just going to put a picture in there. Whoa. User graphics, that's cool. I just downloaded something. I guess it's not going to work because it's a bitmap. Oh, boy.
Landscapers.
I guess we can't put that picture in there right now. Whoa.
Wow.
All right, so I'm going to save this and I'm going to send it to the.
Could you add pictures? Like, say, a certain meme about the L drive?
Oh, I could, but actually I downloaded.
That would be amazing.
So I downloaded this ICC logo and I was going to put it as a background, but it's saying you need it as a different type of file instead of a JPEG. I don't know how to
Do
convert.
I look like I know what a JPEG is?
It's just a file type.
She knows what a JPEG is. There's
I just want
some
a picture of a goddamn hot dog.
there's some converters online, but
Wait, where's Luke?
I don't know. I texted him.
Check. I was gonna say, because him and I had to do those conversions a lot for our project class. Project management.
We're partners in project management, ma'am.
All right.
I know we're
That was
partners,
quick.
but I also
See if that worked. Where to go? Static bitmap. Boom.
Yes. How do you send it to back layer? Oh, it's at the bottom. Are you able to drag that layer down so it's layer 4 instead of 1?
Yeah, you can do it that way, or you can just say send to back.
I mean, yeah. I mean, wait.
Wow. Mm-hmm.
Cool. All right, let's just go with that. Save.
That looks great.
I need to download this to the PLC so that it knows what all these B3s are that we just put in there. I'm just going to leave it running for now.
Are you leaving us for another Zoom meeting?
No, I'm trying to figure out where my meeting control. There we are.
Are you finally gonna kick Nathan?
Dude,
No,
what the heck?
he's been very respectful.
I
Today,
All right.
don't know that I would agree with that statement.
Control Alt Shift H. Good grief. Oh, here we go. Send. Can you guys pin my video so you can see what's going on, or do I need to stop the share?
We can pin your video.
All right. Well, let me know if
Yeah,
you
it's-
can see it very well, and I'll change it. So I'm going to hit transfer.
Well, I can't see it very well because it's very bright in there.
Mm-hmm.
Yeah, I know. I was trying to mess with the screen and everything for it to.
There was like a red circle on it, then it disappeared.
Right there.
Oh,
It goes.
there it is.
The red circle
Now if
was
I hit-
probably his previous program.
So I don't remember how our process even runs, but if I hit that's the e-stop, process enable. Oops.
The latch no longer works.
Yeah, so we need to look at
Is that because we have it set to the momentary or whatever?
I don't know. I have to look at the logic. So here's our
Delete.
oh yeah, that's right, because the selector switch is not momentary. Okay, so we'll have to just change that. So here, you want to watch in the logic what's happening? So here's where I hit that button. See how it becomes true?
Yeah.
Right.
Yeah.
Latch, because before we were depending on the selector button. So all we got to do is go in here and say, we want this as toggle.
How do you have to send that again?
Yes.
Or okay.
Okay. All right, so I'm going to send that. Transfer. Oh, I remember what I was going to do. There, maybe that'll be a little better.
I have extreme doubts.
Can you see it a little better?
Oh,
Yeah.
yeah, kind of.
Yeah, a little bit.
All right, here we go. Process control. Cool. What Greg's doing its thing for a second.
Yeah.
This stayed enabled, so I can disable it, just like a selector switch, right?
Yeah.
And the temp control should start that process. That's a problem.
Will they assign like the same bit? Thought we had.
Yeah, so okay. Temp control bit is B37, and we must have assigned it the same as the stop, B39. So let's go look in our software and see what we did there. Yep. We just didn't change that. So this needs to be 7. Save. Send. Transfer. All right, temp control start. Exhaust fans on, temp control fans on, the heater's on, pilot light's going. And if we want to stop that, we hit the e-stop. That kills that process, but the process is still enabled until we do that. Cool. Anybody want to see it again, or should we move on?
I think we should see it probably 15 more times.
Nope. Anybody besides John?
14 more times.
No. Okay.
I always feel very ignored in this class.
I don't know. I feel like we'd probably see it better if it had LEDs on it.
What?
Put some LEDs
Okay,
on it.
well, we need to watch it a few more times. Add maybe like LEDs or something.
Oh, we need to add LEDs? Okay. All right. So I'm making a list of all the people I need to kick out. I think we got Brady, McKenzie, and John so far. Nathan's like my
And Nathan.
favorite today.
Yeah, but he should be kicked on proxy. You know.
I'm gone. Brad's gone.
All right. Back to this here deal.
Zach, you're doing a great job.
Thanks, Nathan.
You're
All right.
welcome.
Stop
So-
kissing his ass, bro.
Well, he's
Yeah, I was gonna ask you if it stinks in there, brown noser.
Yeah, since they got a little brown on your nose, Nate.
Let's go screen 2. And we'll call it, what all are we monitoring? Let's say temperature. Temperature.
Hey, Kenzie, while he's setting this up, you want to hear a really funny joke?
Sure.
Women's rights.
Nate has been added to the list to cake.
All right. I'm not really sure what to say now. We can have, what can we have? We can have an analog meter. Let's do that. And we can have one look like this. And we'll call this Fahrenheit. And right now it's 0, 20, 40, 60, 80. Tag name, what is our tag? F8 for Fahrenheit.
For
F8.3
Fahrenheit, it
is
was
Fahrenheit.
F8.3.
F8.3.
That's 3.
Yeah.
Yep.
Number of major divisions. Display range 0 to 100. Meter movement cockpit, needle. And then this, so this is what the graph will look like. And this should show temperature in Fahrenheit. And I don't think we're going to go 0 to 100 there, are we? We should go to like 50 to 150. Because we're
Like-
staying between 80 and 120 degrees Fahrenheit, right?
Yeah, so will it automatically jump?
No, it'll show you what that range
The
is.
0 on that meter are low range. So like our 80.
No, it's going to show you whatever the F8 value is.
Okay, so we'd have to change the values.
Before we do that, I'm going to move this guy. Let's see. So this will be Fahrenheit. There's a reason I'm leaving room down at the bottom. But if this is Fahrenheit, we want that to be like, well, I don't know, 50 to 150. And basically, because we want it to stay around 100 degrees, we're going to want that needle to stay right in this little silver part, right? Anyway.
Yeah.
Show digital display. Okay, so this little box in here will show us what the temperature is in that F8 value. All right, now let's do our Celsius one. So this is going to be 0 to 100. Everything's going to be same except F8, what is our Celsius value?
F8.1.
All right. So this is Celsius, this is Fahrenheit. Now we need a way to navigate from screen to screen, right?
Right.
So let's add some more screens that will just be blank for now, but we'll have one. So we got one for temperature. We can have one for fan speed. Is that right?
Right.
Any
Yeah,
other
that's a good
analog
one.
values that we want? What's that?
I think that's a good one. The fan speed.
And then we need a way to go from screen to screen. That's going to be under our tools, screen selector. Three columns, one row, screen, all of them. I won't get too fancy with this. And I'm going to copy this and put it on all three screens. Cool. You try it out.
Sure.
Yeah, sorry, I didn't know I was muted.
Transfer.
Ooh.
All right. So now we've got control screen, same thing. I'm going to enable the process. I'm going to do touch control start. If I go over to the temperature screen, it's 67 degrees Fahrenheit or 20 degrees Celsius in here.
Wow,
Kind of cool, huh?
that's really cool.
But you guys can't see that very well, can you?
No, I can't see. It's just a white screen.
No,
there.
yeah, it's just a white screen for us.
When you had your hand over the camera, like they like dimmed it, so I was able to see it better. I can only like barely see it when you put your hand over the camera for some reason.
I think the background's too bright.
Yeah, the background's too bright.
What'd you do before? You did something and it made it where you could see it easier.
I don't know. I should probably just unbolt it from the trainer. I wanted it up there so you could see like the outputs going at the same time.
Yeah.
I think the first screen was easier to see because we had that ICC logo in the background, so it's a dark blue background, and it made it easier to see the buttons. But since this screen doesn't have it,
Probably.
Do we need a darker background?
Maybe. Maybe
it
put like
yeah,
a
I'd
black
say
or,
try a darker background.
black or like a dark blue background or something.
Yeah, agreed.
There, I can see it a little bit better. I can't see the numbers or the buttons, but I can see like the blue and the red.
Well, at least you can see the bar graphs, right?
Yeah, a little bit. A little bit, yeah. Right there you can. Clearly.
And
Yeah.
what we'll do for the fan speed is we'll make it like a digital display instead of a meter, and then you'll really be able to see it a lot better.
Okay.
Okay. You guys want to stop or you want to keep going?
Matter
I
to me.
have to get going back to work.
Yeah, I got plans. I gotta go drive out of state.
All right. Well, we'll say Monday we'll do the fan speed, and we will. Monday we'll do the fan speed, and I'm going to go over with you what the final is going to look like.
Okay.
Because I have a process with this trainer sort of written up. Does everybody understand what we're doing with that as far as the labs go and your overall grade?
Yeah.
Yep.
I have a pretty good idea. Yeah.
Anybody having any trouble with anything else?
Nope.
I just gotta get the quizzes done.
I lost the password to the CNC labs.
It's
What is
really
it?
tough. It's just Zach.
All lowercase.
Yeah.
Are you gonna post that motor quiz?
No, we're doing it.
That's going to
during
be in
class.
person on Wednesday.
Oh, okay.
Not in person, but everybody needs to log into Zoom before I open it up.
We all need to travel to Zach's house to do the quiz.
Bring your laptops. We'll all sit in my garage and hash
Okay.
We have a LAN
Be
party
there.
and play Doom. Everybody download Doom on their laptops.
like the original Doom.
Yeah.
Okay, that'd be dope as fuck. Just saying.
So when are finals gonna be? When's the last day of class? Is that May 10th now?
I don't know.
Graduation May 16th.
They extended the semester by a week, I think. But how we're gonna let's think about all three of my classes. 231, the robot, CNC, there is no final for that class. Just make sure you get all your stuff turned in. This class, we're gonna have to schedule times over the course of how many people are in this class?
Probably like 12.
Yeah. I tell you what, guys, if you started them CNC labs, they're not up to date. So don't assume you know. I messed that up.
No,
I've been looking through the CNC labs or the forums that you posted, and like I'm having trouble finding like half the information on them.
It's all in there.
it is all in there.
I've done them all.
I've done 3.
I've done 2.
Hey, Zach, when do you think we're going to start scheduling when we're going to be doing the final set? Because I'd like to maybe talk to my boss and maybe take 1 or 2 days off for
Okay.
that to study.
Yeah.
Tomorrow, Aaron. Tomorrow's the finals.
Shit.
I'm ready. Let's do it.
Really, for my classes, there's only, I mean, what we'll do for 230 is when everybody's got their programs written, and in that class, you know which class I'm talking about, right? 230.
Yeah.
Yeah.
You're coming up with your own process, and you're going to do your own HMI.
Oh, whoa.
What?
Yeah, and then you'll just turn in your wiring diagram, and we'll do a Zoom meeting where each group presents
Okay.
what you came up with, and we'll run the process on the trainer, show the HMI.
That's super cool.
So that'll be 1 or 2 days. We could probably do that in 1 day, one morning, and then
With the wiring diagram, shouldn't everybody have the same wiring diagram?
you have a template, but you have to show. You got to show me, where those things are wired up.
Okay. Yeah. Okay.
It's going to take some doing. I mean, I wouldn't wait till the last minute with all this stuff, guys. You're going to have to look up mod, like PLC mod, like Compact Logic's module information and show, you know, which pins those are landed on and all that. So don't wait till the last minute.
I didn't even realize we had to do a wiring diagram for that.
Yeah, I didn't either.
I did. I just have not been doing it. But wouldn't it be the same for everybody because everybody has the same trainer?
Somewhat, but not everybody's using the same inputs and outputs. Right?
That's true. Yeah, that's true.
No, but aren't we all using the same inputs and outputs? Because like,
No.
No, not everyone. No, not everyone has the same exact process.
I know
No,
what you're thinking. You can all get together and come up with one and
that's
share
not what I'm
it.
thinking. But what I'm
Okay.
oh my god.
Stop yelling, Nathan. Just speak. Use your
No.
words.
If you're right in the sense that if every group was using every input and every output, it would all be wired up the same. Yeah.
Okay, so you're saying with the wire diagram, I don't have to put like if I'm not
Stuff we're
using
not
it.
using.
Yeah.
Yeah, if you're not using the bottom red pilot light, you don't have to show where that's going.
All right, that was I guess my question.
Okay.
All right, I'm leaving. Bye.
And who said they
Okay.
didn't know about the wiring diagram?
I did, but I'm sure you mentioned it.
Do you know where the template is?
Yeah,
The
I've
shared
seen
drive?
it in there.
Okay.
I think so. You had a bunch of them at one point. You don't want it like the one I sent you. You want it different than that.
You can use whatever you want. I thought it'd be easiest if everybody took that and it has all the components on it, and I was just trying to make it easy for you.
All right. Yeah.
No, I don't want like a block diagram. I want the wiring diagram.
I didn't send you a block diagram.
Okay.
I don't think. Which you got a bunch of
I'm sure we'll get it figured out.
in here. Is there one that's labeled like template?
Yeah, in each one of your groups. Hang on, I'll show you.
Oh, okay. Here, oh, okay. Group 2 wiring diagram template.
Yeah.
See, that's what you want like that. You just got. So what do you want? Just like this is weird. So you just want lines drawn on it to what it goes to? You got a picture with 2 fans, 3 buttons and a selector switch, and like a bunch of components drawn out on there. And then a list of inputs and outputs on the left. That's the
You can use this however you want. You don't have to.
That's interesting.
But if you're using the strobe, I mean, I can download it and show you what I do. But I would just draw a black and a white or gray or however you want to do it coming off of the strobe light and show me where it goes. You know, you can draw a power supply. You could have a terminal strip in the middle here that's labeled like these 9 screws are 120 volt plus, and these 9 are neutral, and these 9 are plus 24, minus 24, you know, however you want to do it. I drew this up, 1, to hopefully make it easier for you. 2, all the PLC outputs and inputs are on here. And 3, it shows you which components you have on the trainer, right?
I think I have an idea of what to do with it.
So this is for our groups.
Yeah.
Or we could also use it on the final, maybe. Like as a reference. Obviously, we would have to tell you our logic and everything.
Yeah, I don't care if you use it on the final.
All
right.
I'm gonna go.
Okay.
Yeah, that's fine. I didn't know that that's what you were looking for. No problem. I'll do one up.
Okie dokie.
All right.
You guys have a good weekend.
You too, brother.
See ya.